Okay, so to finish number 4b, we had already found the time and the half time, and now it wants the maximum height. And remember, the maximum height happens at the half time, at the time it takes to go up. So when we do our delta dy max, we have to use the 14.43. So VIY we had as 200 meters per second, and it was sine of 45. And then our TU is 14.43 seconds. Plus 1/2 negative 9.81 meters per second squared times the 14.43 seconds squared. Okay, and when you do this, the first term, delta dy max, equals, the first term equals 2040.8. I think it's 0.7 something meters. And the second, I must have rounded up my time, the second term is 1020.3 something. Really, if I hadn't rounded, they would both be exactly, one would be exactly half of the other, and I'm not going to go back to find out where, it's because I rounded my time. And so when you subtract them, you get delta dy max is equal to 1020, and it should be 3 something meters, okay? So again, remember you need to subtract because the A goes in as a negative. The third part of the question wants to know how far forward. So I'm going to do it up here. I'm looking for delta dx. And so my VIX is VI cos theta. My AX is 0, so this disappears. So it's going to be delta dx is equal to 200 meters per second. Cos, it doesn't really matter because when it's 45, they're the same. And then this time, I want how far forward. I need to use the whole time. So 28.86 seconds, and I get a delta dx of, sorry, I was just checking, yeah, so this was 5. I'm checking your sheet. But I think it's really closer to 4 if I didn't round. Delta dx back here is equal to, according to your sheet, 4081.4. And again, depending on how many decimals you kept for your time, the 0.4 might be a little bit different. Okay, so that's number 4. Number 5. Number 5 says a ball thrown from central field to home plate at an angle, being caught at exactly the same height as it was thrown. It is thrown. It takes only 3 seconds for it to travel. Okay, so it's a ground to ground, going up and coming back down, so it's caught at exactly the same height. We have our x direction, we have our y direction, we have our VIX is equal to VI cos theta, and our VIY is equal to VI sine theta, right? Because here's x and here's y. We know our AX is 0, and we know our AY is 9.81 meters per second squared, and that's down. And so it says it's caught exactly 3 seconds after it is thrown. So delta t for both sides is 3 seconds. And then it says how far in the air did it rise? Sorry, I missed it. Horizontal distance is 60 meters. How far in the air did it rise? What is delta dy max? And with what velocity was it thrown? So we need our VIY and our VIX. Okay, so if you take a look at your x direction, you can find your VIX. So when they don't give you a VI or a cos theta, you probably want to just solve for VIX. So in the x direction, you can do delta dx is equal to VIX delta t plus 1/2 ax delta t squared. This goes to 0, and just solve for your VIX. So delta dx over delta t. And it said it was 60 meters and 3 seconds. So your VIX is 20 meters per second. Okay? And that's going to help us to find our VI. Then in the y direction, we can use our time up thing to do the same thing. We can use our time up and we can say, so AY is equal to VFY minus VIY over delta t. And if it's up, this is TU, and this goes to 0. And now I can find my VIY, because my negative VIY will be equal to AY delta TU. So my negative VIY, if you don't want to take your negative over, will be equal to negative 9.81 meters per second squared. Time up, well, the full time is 3 seconds, so the time up has to be 1.5. The negatives cancel, and I get a VIY of 14.715 meters per second. So with these two, I can find my VI and my theta. So I'm going to do that before I do the second part, just because I have them. So I have 20 meters per second this way. Oops, I should have written it on the bottom. And I have 14.715 meters per second going up. So this will be my VI. For my, get that 20 out of there because it's in the way. This will be my VI, and this will be my theta. Okay, and this is 20 meters per second. So square them, add them together, and take the square root. And when you do, you get 24.83 meters per second. And then do inverse tan to get the angle of 14.715 meters per second over 20, and you get an angle of 36.344 degrees, and that of course will be WRT with the ground. Okay, so that's the second part of the question, what's VI? The first part wants to know maximum height reached. So for maximum height reached, why is it doing that on this one? So for maximum height reached, we're looking for delta dy max, and that's equal to VIY delta TU plus 1/2 AY delta TU squared. So delta dy max is equal to, we just found this to be 14.715 meters per second. We found our time, they gave us the total was 3 seconds. We have to use the half. So 1.5 negative 9.81 meters per second squared, 1.5 seconds squared. Delta dy max equals, first term is 22.072 meters. Second term is 11.036 meters. When you subtract them, again, and they should be exactly half if you don't round anything, and so 11.036 meters. Now, just a little note for those of you in case you're messing up here. If you accidentally forget and put the full time in for the delta dy max, you're going to get something awfully close to 0 here. Okay, and that should be your little hint that you messed up. Okay, so if this works out, if delta dy max works out to be really close to 0, really close because you might have rounded your time, then go back and realize you didn't use your half time, you used your full time, because full time puts it back down to the ground, so it should be really close to 0. Alright, so that's number 5, and really it was 5A. Alright, there you go, your homework.